Welcome to the deep dive. For the past few years, we've all been living in this era of generative AI. You know, systems that are incredibly impressive, fluent, sometimes plausible.
Sometimes.
But the stack of sources you sent over for this, it confirms something huge is happening. 2025 is the pivot point.
It really is.
We're moving out of the age of just generative AI and into the age of, well, verifiable intelligence.
Exactly.
So our mission today for you is to really dig into the engineering behind this shift. We're going to look past the headlines from DeepMind, from Google Research.
Right, and quantum AI.
And see how they actually built these systems. Systems that can reason, that can act, and this is the crucial part, that can verify their own work against actual reality.
It's a massive shift. And what's so fascinating here, is that the game isn't just about raw size anymore. It's not about who has the most parameters.
So it feels like last year's news, right?
It is. The whole focus has shifted to the sophistication of the AI's thinking process at inference time. It's all about how well it can ground its output in actual logic.
So it's moving from it sounds right to it is right, and here's the proof.
Precisely. Correctness, not just sounding smart.
Okay, let's unpack this. We'll start with the brains of the Operation Gemini 3 and Gemma 3. Then we'll get into the agents that actually use those brains, and then we finish with how this stuff is making brand new discoveries.
Sounds good.
All right, let's start with Gemini 3. The sources are pretty clear. This is the absolute apex of their scaling efforts. It's built to push AI into what they call system 2 thinking.
That slow, deliberate reasoning part of our brain.
Exactly. And the engineering trick to deliver that kind of power is this architecture called sparse mixture of experts, MOE.
And MOE is all about solving the cost problem.
Yeah.
I mean, if you have a dense model with 1 trillion parameters, you have to light up all of them for every single word.
Which is just wildly expensive.
And slow.
Unbelievably slow. So the MOE approach in Gemini 3 is smarter. It still has that massive, multi-trillion parameter count.
But when it's processing something, a little router just picks a small, civilized subset of experts to do the work.
So you, the user, get all the knowledge of that giant model, but with the speed and the cost of a much, much smaller one.
That's the idea. And the sources mentioned the big challenge was something called expert collapse, where the router gets lazy and sends all the work to a few experts.
And they fixed that with some clever math during training.
Right, some auxiliary loss functions. But the real breakthrough where this verifiable theme really kicks in is this thing they call deepthink.
This goes way beyond just chain of thought, right?
Way beyond. Deepthink is this internal search process optimized with reinforcement learning, but, and this is key, it's post-trained for correctness, not for what sounds nice to a human.
So it's not trying to please me, it's trying to be objectively right.
Exactly. And the way it does this is with thought signatures. When you give it a hard problem, it starts generating these internal thought tokens.
An internal monologue, basically.
It's literally an exposed internal monologue where it plans, it critiques its own logic, it backtracks. And what's crazy is the API lets you set a thinking budget.
Wait, so I can literally pay for it to think harder?
You can trade a few extra seconds of latency for a measurably deeper level of reasoning. You're buying it more time to think.
That is just a wild level of control. Okay, so while Gemini 3 is pushing raw scale, Gemma 3 is focused on efficiency. It's tackling that massive memory problem, the KV cache.
Yeah, key value cache bottleneck. Yeah, with these huge context windows, like 128,000 tokens, the memory you need just explodes.
So how does Gemma 3 get around that?
With a really clever architectural trick. It's a hybrid attention strategy. They use a 5-to-1 interleaved attention ratio.
Okay, 5-to-1. What does that actually mean for the listener?
So imagine for 5 layers, the model is only using local attention. It's just looking at a tiny window of about 1,000 tokens.
Keeps the memory footprint tiny.
Exactly. But then, every 6th layer, it uses global attention. It zooms out and looks at the entire 128,000 token document to get the big picture.
So it's constantly syncing up the local details with the global context.
And that's what makes it work.
Yeah.
And to make sure it doesn't get lost in that giant context, they had to tweak the positional encodings.
Throw P embeddings.
Right. They amplified the base frequency on those global layers from the standard 10,000 all the way up to 1,000,000.
1,000,000, and that stops the lost in the middle problem.
It ensures the model can tell the difference between token 5,000 and token 125,000 with high precision. It knows where everything is.
So it's not just holding data, it's understanding its structure.
Exactly. Okay, so now we have these incredible reasoning engines. The next step is getting them out of the text box and into a world they can actually control. And that's Genie 3.
The world model?
The world model. It can generate a fully interactive 3D environment just from a text prompt.
So we're not talking about just a video clip. This is a simulation with physics and everything.
That's the leap. And the technical problem they had to solve was that video data isn't labeled. You don't know what keyboard inputs made a character jump.
Yeah.
So Genie 3 uses latent action models, or LAMs. It learns to infer the action that must have happened between two frames. It creates its own universal controller.
The sources claim 720p at 24 frames per second with emergent object permanence and consistency. So I can say, make it rain, and the world.
The world obeys. It becomes a neural game engine. And its main job is to be an infinite data factory.
Ah, so it's a training ground for other AIs.
Instead of coding a million different robot training scenarios, you just prompt Genie, a cluttered kitchen with transparent objects, and boom, you have it.
And the agent that lives in those worlds is SIMA 2.
The scalable, instructable, multi-world agent.
And it uses Gemini as its brain, right? To translate a high-level command like find a car and drive to the safe zone
Into the low-level keyboard and mouse clicks that a human would make. It plays the game just like you would.
And the big breakthrough there is the generalization. Getting it to work in a new game without a total meltdown.
The zero-shot generalization, yeah. And they did that using bridge data, which is a mix of human gameplay and synthetic data that Gemini itself created to fill in the gaps.
But the part that really stood out to me was the autonomous self-improvement loop.
Oh yeah, this is where it gets really interesting. SIMA 2 doesn't wait for you. It literally gives itself missions.
I should try to climb that mountain.
And then it uses its internal Gemini brain to grade its own performance. It's generating its own curriculum and marking its own homework. It learns without a human in the loop.
From learning in simulated worlds to generating and verifying actual new knowledge. This is where that verifiable part really comes to life.
It is. This is the jump from that sort of fuzzy LOM intuition to hard, formal logic. And the poster child for this is AlphaProof.
The system that got a silver medal equivalent at the International Mathematical Olympiad.
Which is just a monumental achievement in abstract thought.
So how does it stop the hallucinations, the math errors we see in other models?
It's a neurosymbolic architecture. It's a loop. First, Gemini acts as the creative part. It generates potential proof steps.
The brainstormer.
The brainstormer. Then a formalizer translates those ideas into a super strict language like Lean. And finally, a verifier checks the logic, if it fails.
The feedback goes back to Gemini to try again.
It's a closed loop where intuition is constantly checked by rigorous proof.
And they applied that same idea, that fusion of AI and algorithms, to code with AlphaVolve.
Right. Here, the LLM isn't just writing code. It's acting as an intelligent mutation operator inside an evolutionary algorithm.
So instead of just random changes, the LLM is suggesting smart semantic inits to the code.
Exactly. The faster variants survive and breed. And the result was staggering. AlphaVolve discovered a totally new way to multiply 4x4 complex matrices.
Using only 48 scalar multiplications.
48, which broke a record that stood for, what was it?
56 years. Stressen's algorithm needed 49.
And because matrix multiplication is basically the engine room for all of AI and graphics, that one little optimization makes everything faster. A machine just found a better way to do math than we've known for half a century.
It's AI breaking fundamental barriers. And we see the same power being applied to hard sciences like genomics.
Yeah, genomics has this huge, long-range dependency problem. A tiny change way down the DNA strand can affect a gene.
So you need massive context.
You need massive context. And AlphaGenome scales its input to 1 million base pairs. 1 megabase. It can see the entire gene locus at once, predicting expression, 3D structure, everything.
Then there's cell 2 sentence. This one is just brilliant. They literally turn biology into a language.
They convert RNA sequencing data into text tokens. So the model learns the grammar of how cells work.
And can then predict things like drug response.
They're applying the same scaling laws that gave us ChatGPT directly to the machinery of life.
We have to talk about the physical hardware, too. The push for verifiable quantum advantage on the Willow chip.
105 superconducting qubits. It's a big deal. But the key, tying back to our theme, was the verification. They had to prove it was quantum.
And they did that with the quantum echoes algorithm measuring these OPOCs.
Out-of-time order correlators. And that's so important because OTOCs are a distinct fingerprint.
Yeah.
They prove that what you're seeing is real quantum weirdness, not just classical noise.
The claim is robust. And the speed up.
The speed gap is just astounding. The calculation on Willow took 2 hours to simulate the same thing on the Frontier supercomputer.
The fastest classical machine on Earth.
Would take an estimated 3.2 years. That's a 13,000x speedup. That is a real, defensible claim of quantum advantage.
And all of this is running on new silicon. The Ironwood TPU v7 is a huge part of this story. It's an inference-first design.
Right, it's optimized for running these complex reasoning models, not just for training them. It scales up to over 9,000 chips, 42.5 exaflops. But the magic ingredient is the optical circuit switches, the OCS.
So for the listener, that means they can physically rewire the network between the chips on the fly, right?
Instantly. It's like having a highway system where you can redraw the lanes in a microsecond to prevent traffic jams. And for those sparse MOE models, that's absolutely critical for efficiency.
That's what gets them that 2x improvement in performance per watt. It's the plumbing that makes it all work.
And that efficiency scales up to the planetary level. Look at WeatherNext 2. It moved from a single prediction to probabilistic forecasting.
Which means it's not just giving you one answer, it's running thousands of possible future scenarios.
Right. And that lets you better predict those rare, high-impact events. A cyclone that rapidly intensifies, a sudden heat wave. It's about predicting the outliers. And it runs 8 times faster.
And then there's FireSat, which uses Edge AI.
A satellite constellation that spots fires as small as 5 by 5 meters. The key is it processes the data on the satellite.
No beaming massive images down to Earth.
Which cuts the alert latency down to about 20 minutes. That's a verifiable improvement that saves lives.
And finally, bringing it all back to the individual learner, to you, is LearnLM.
A family of models fine-tuned specifically for education. It uses learning science, things like Socratic questioning and scaffolding, to be a real teaching partner.
It's more than just a search engine, it's a tutor.
Exactly.
So when you pull all of this together, what's the big takeaway? To me, it feels like we've left the era of the lonely chatbot and entered the era of the compound system.
That's a great way to put it.
It's the convergence. You have the deep reasoning core of a Gemini 3, the ability to act in the world with a SIMA 2, and this absolute demand to verify its results with an AlphaProof.
And what that means for you as a knowledge worker or just someone trying to learn is that these systems are no longer just finding existing information. They are actively creating new verified knowledge.
And that leaves us with a really provocative question to think about. If AlphaVolve can break a 56-year-old math record and AlphaProof can get a silver medal at the IMO, how do we, as human scientists, as creators, work with these things?
Right. Where does our intuition fit in when the machine itself is doing the fundamental acts of discovery and verification?
That tension between our creativity and this new, verifiable, autonomous computation.
That's the defining question of the next decade, isn't it?
It really is. Something worth mulling over. Thank you for joining us on this deep dive.